How we going? Rob again. We're talking VLANs, so we're getting into switching a bit more now. So far, if we've followed the process of this network, and you haven't jumped straight into this one, what I've done is built this network. We've got RIP running through there. Should all be working actually. I've just changed it and haven't tested it, but anyway. Those networks have changed their IP addresses, so we're on a 192.168.30 network up there now, 192.168.20 down here, and this network is 192.168.10.0, and I've subnetted it. I've got 3 networks, so again a fixed length subnet mask /26, so the 0 network, the 64 and the 128 networks. And what I'm going to do is create VLANs. I've added 2 extra switches, and I've put a bit more configuration on here. Probably need to talk about VLANs for a bit, and try and discuss what we're actually doing here. So I've got some configs, or at least design that I want to put in. I've said that there's going to be a VLAN number 22, which I'm going to call admin, a VLAN 33 for staff, and a VLAN 44 for net admin. And I've said down here that VLAN 22 will exist on this switch and that switch, on ports 3 to 10, and VLAN 33, should put that up there. Oh, come back. Oh, it doesn't like that, does it? Is going to exist on ports 11 to 20 on those 2 switches. So why would we want a VLAN stuff? So pretty much what I want is this PC, which is plugged into port 15, because it's in the range 11 to 20, is going to belong to VLAN 33. And that will belong to the same broadcast domain or the same network as this PC over here, which will also be plugged into, let's go for port 17 there, which is also part of VLAN 22, but on a different switch. So that implies that these 2 machines are on the same network, but they are separate from these 2 machines, the server and that PC. These belong to VLAN 22, and they will be separated at layer 2, which is where VLANs happen. So at your frame level, this machine will not be able to ping this machine, even if they're on the same IP address scheme, unless they go through some router. And there's some fudges you can do, but we won't go into that. So the way this is looking at what we want to design is, even though that server and that PC there can actually sit in the same room, in fact be side by side physically, logically they are on separate networks. And that's what we want. We want to segregate the networks out to give ourselves a bit more control over the size of the network and the security of the network. And this is all done through switches. So we won't even be touching this router to start. I'll do another episode on setting up router on a stick or into VLAN routing. Won't quite get into, oh no, might do, layer 3 switching, thinking about it. But for now, we're just going to set up VLANs to separate that machine, or VLAN 22 machines, from VLAN 33 machines. So this machine can ping that one, good. That machine can ping that one, but that one there, that PC will not be able to ping the PC down the bottom here when we're finished. So there's a bit of configuration we've put in, or not configuration, but information in our design, and we're going to go through and build it all. Okay, so a few things we need to talk about. Again, these switches here where end devices plug into, so PCs, servers, printers, access points, that sort of stuff, these are edge devices. The ports here will be edge ports. So ports 3 to 10 and 11 to 20 are edge ports where these devices plug in. Those switches are called access switches. They're connected through this third switch to give ourselves a bit of a loop and have a bit of redundancy built into the system. When you build bigger and bigger networks, so branch and enterprise level networks, you're going to have a lot more switches sitting in the kind of backbone area of your network. So this is, at the moment, is a compressed core. So this handles distribution and core functions for the switches. In our case, we're just using a bog standard 2960 just to go through the process. But in production environments, you'll have very high speed connections to that switch. Now the connections from switch to switch are going to take our VLAN information. They're going to take VLAN 22 information up there and down there. They're going to take VLAN 33 from that switch up to that switch and down to this one on the bottom right. And we've got another VLAN, VLAN 44, which is going to be the IP addresses on our devices. So for network administrators, they need to remote into our switches. Switches will need an IP address, so we can get in. And we're going to separate that network, so we're going to have a VLAN 44 running in there. Now, each of these VLANs, what separates one VLAN from another is when a frame comes in from a PC into the switch, it's a normal frame if you're using Ethernet. Once it goes out of the switch and down these links, which are trunks, they are tagged. And they're tagged with the VLAN that they originated from. So if it's VLAN 33, this PC wants to connect to this PC, then the frame goes into the switch, and when it comes out of the switch, and it'll go up to this part, to that top switch there, it'll have a tag put into the frame that says that this frame belongs to VLAN 33. And the switches will use those tags down these trunks to separate our information. So we need to get a bit of an understanding of how this is all working. First of all, we're going to go through and configure everything and go from there. Okay, so hopefully it's not too confusing. It's a bit weird, VLANs, but let's hop in and start doing it. So down the switch on the bottom left, we'll start with this one. We're going to do pretty much the same configuration on the switch on the right, and there'll be a difference to the switch at the top there. Because it does not have any access ports, so we won't be putting these VLANs onto that top switch, only the edge devices. Okay, so let's hop into our first switch there. So switch 2 is what we've ended up on. We've got the standard configuration on this switch. The next switch over there, I've still got old configuration, so we'll take stuff off as we go through. And the top switch is all fresh as well, but standard configuration. So Cisco, we get into our privilege exec with enable, and class is the password there. So if we just do a quick show run and see what we've actually got there. We've got service password encryption, we've got switch. For some reason I've got a password in there which I don't need. No IP domain lookup. There's all our ports. Nothing is done on our ports at the moment. We have VLAN 1 interface, which we're not going to use this time. We actually want to get everything off VLAN 1 from a security perspective. We've got our banner, and we've put a password on our console and our VTY lines. One little extra bit down there which we may not have talked about before. I've said that the transport input to the VTY lines is going to be telnet, so we can't use anything else. So that's the standard configuration. Okay, so configure terminal, and we're going to config mode, and this is where we start putting in our VLAN information. So what we actually want to do is create our VLANs first. You can create them on the fly when we actually allocate ports to a particular VLAN, but when we do trunks and put native traffic onto a VLAN, the system does have a bit of a a hissy fit with putting native traffic onto a VLAN. I've just chucked in a term there called native traffic. Native traffic is untagged, and there are protocols that run from switch to switch, like dynamic trunking protocol, spanning tree protocol, or spanning tree is per VLAN, sorry, and a few other Cisco Discovery protocol, which are not dependent on a particular VLAN, so they will be untagged. And we want traffic to go from switch to switch untagged, so we need to actually have it running across our network. You have to have it the same at both ends. So when we get into trunks, we'll see some nice errors come up, which is correct. So native traffic goes up our trunks as well. So pretty much what we're saying is, let's create all our VLANs first, and we just create them by typing in VLAN and then giving it a number. So these are the numbers I want in here, and the name that I'm going to give that VLANs, because it should be described, is those names there. So VLAN 22, hit enter. Name is going to be admin. That's for the administrators of our business. So clerks, accountants, that sort of stuff are going to exist on this network, and they're going to be separated from other staff. So the name should be descriptive of what we want to do. Now at this point we can type exit, or we can just type VLAN 33 and go straight over the top. So the name for this one is going to be staff, and then VLAN 44 is going to be our network admin. I should put name in there, shouldn't I? Talking and typing at the same time, it's a skill which I don't possess. So there we have it. We've actually created our 3 VLANs. So let's actually go back to privileged exec mode and see what we've actually done. Let's just show Vlan Brief. So show Vlan Brief, that command there shows us a portion of a file called vlan.dat. So switches will end up with a running config and a startup config if you've saved your running config, but they'll also end up with a Vlan Brief file, or a vlan.dat file. And when you're cleaning up your switches, you need to actually clean up that that file as well. We can see that file if we do a directory and dir, and it gives us a directory of your flash, and if we haven't seen this before, there's our operating system, there's our startup config, and there's that vlan.dat. So if you want to wipe all your configs off your switches, which is a really good thing if you pull your switches out, get rid of all your configs, you get rid of vlan.dat, and you get rid of config.txt. So make sure you do those when you tidy up, or at least, and sell your switches, whatever. Okay, so let's go back to show Vlan Brief, because I've digressed a wee bit. Now what show Vlan Brief does is says which are the VLANs that are actually in here. So VLAN 1, 22, 33, 44, 1002, 1003, 1004, 1005. The default ones which you cannot get rid of are these 1002 to 1005, so fiber, token ring, I'm not too sure what TRNet is actually. So they exist on the switch as VLANs, and VLAN 1, which is the default. So every switch comes with every port. Yeah, we can see on the right there, all these ports that are on this switch, so FA01 to 24 and gigabit 01 and 2. All these ports are added to VLAN 1. You cannot delete VLAN 1. Good security practice is to actually get everything off VLAN 1, and that's our bit of an aim today. Let's see how we go. And we want to put it onto our own VLANs, and then we can control everything. So we've added these VLANs. So by typing in VLAN 22 and then put the name admin, we've actually put that little portion in there. So that's what we've done so far by adding our VLANs. So there it is, VLAN 22, name admin, VLAN 33, name staff, VLAN 44, name netadmin. And show Vlan Brief gives us this information. So far so good. We're tracking well. Okay, so we've got our VLANs in there. What we'll do next is set up our trunking. So what we want to do is set up these interfaces, whatever's plugged into these, from switch to switch is actually a trunk port. So it's going to configure terminal. So trunking has a few interesting bits about it. We'll go in and work our way through it to start, and then come back and talk a bit about it. So on the bottom two switches, I've set up ports 1 and 2, and that's FA0, 1 and 2 as what I'm connected to from switch to switch, so those will be my trunk ports down there. Switch up the top here has actually got 3 trunk ports, because that connection to the router is going to be a trunk port as well. We won't do it in this video, but we'll do it later. Okay, so interface range, so it's a slightly different command that we've used before. Fast Ethernet 0/1 to 2 is what I want to configure. So we're using this new command, the range command. So whatever we put in will affect interfaces 1 and 2 on this switch. Now this is a layer 2 switch, not a layer 3, which is kind of handy for us, because this layer 3 has a couple of other commands we'll put in. But we'll just go in and put the correct commands in here. So switch port mode, and we'll put a question mark in there. So the command we type in is switch port mode, and we've got 3 options here. Within this dynamic one we have 2 options, so there's kind of 4 options in there. What we're going to do is just force it to be a trunk. We're not going to use a thing called dynamic trunking protocol at this point. Dynamic trunking protocol says that if one side is a trunk, so let's say that top switch up there is a trunk, and the bottom side here we set as dynamic. Let's just go and have a look at what it is, dynamic. And there's auto and desirable, so auto and desirable. So if we went dynamic auto on this port, or these 2 ports, if the other side is set to trunk, then this one will negotiate through dynamic trunking protocol and set itself up as a trunk. If the other side is set to dynamic desirable, then this side will go trunking. If it's dynamic auto at the other side, then it's not too sure. And if it's an access port at the other side, then it will stay as access. So dynamic trunking protocol is a way of connecting from switch to switch and actually negotiating. And there's a subtle difference between dynamic auto and dynamic desirable. Desirable really wants to be in trunking mode more than anything. And the only time it won't go into trunking is if the other side is access. But a bit beyond where we want to play at the moment, so let's just force it to be a trunk. So switch port mode trunk is the actual command we're going to put in there. Now we've pulled the whole thing down. You can see the lights have all gone off. It's going to have to renegotiate spanning tree and all the rest, but that's okay. You just type switch port mode trunk. Now what we're going to do next is actually type in switch port trunk, and we're going to take the native traffic off VLAN 1, which it is at the moment, and put it onto VLAN 44. So I should have actually plugged it in there, shouldn't I? Say that native traffic goes into that VLAN. That's not the route I want that switch. So switch port trunk native VLAN 44. So we're saying that out of these 2 ports, any native traffic is going to go up VLAN 44. It's still not tagged, even though it's got VLAN 44 on it. But we're saying that it will go up this port. Now we should be getting errors from the other side because native traffic off the top switch and the switch on the bottom right there is going through VLAN 1. So native traffic has to match both sides. So this switch on the bottom left, native traffic is going through 44. The top switch has to have native traffic coming in on 44 and sending it out on 44 as well. So we should be getting errors, but at the moment we're not. So that's okay. Let's exit that. So far so good. Even though we've got errors in our network and it's not popping up with errors here, we should have native VLAN mismatch errors popping up. Oh, speak of the devil. There it goes. So Cisco Discovery Protocol says there's a native VLAN mismatch. Our native mismatch discovered on Fast Ethernet 01, which on ours is on VLAN 44. And it's having a conflict with switch 1, which is this top switch there, where its native traffic is still running on the default, which is VLAN 1. So that's an error that we expect because we haven't configured all the switches yet. So if you do see that error, just make sure you do all the switches and then life is good. In fact, let's just go on and get rid of that error now. So let's go through the process again. So let's go on to this top switch. And it's got our nice little error. So Cisco enable class conf t. We need to create all the VLANs on all these switches. So let's go into it again. So VLAN 22 was popped up with an error there. So name is admin. VLAN 33, name is staff. VLAN 44, name net admin. Ah, got that one wrong again. This time not as bad, eh? Name net admin. Okay, let's exit that. Interface range. Now we're going to go and set up our trunks. FA0/123. Because on this one we've got 3 connections on this switch which will be trunking. Then our switch port mode is going to be trunk. We're going to force it to be trunking unconditionally. And our switch port trunk is going to put native traffic onto VLAN 44. And you can see I've just shortened that. Now we should, well, we've got a little change in our lighting there. Now Cisco Discovery Protocol CDP should pop up to say that this link now has been solved. So we should, let's just fast forward a bit, go back and have a look at that one. No, still taking its time. We do have a native mismatch to switch to twice, so down this path. It should pop up relatively quickly. It does it on real gear a lot quicker than Packet Tracer, where this is now correct. The native VLANs are working all, they're correct. Okay, so let's do all those commands again, and now we'll do it on switch 2. Okay, so conf t. Let's create our VLAN. So VLAN 22. You don't have to put name in, but makes sense. So name is admin. VLAN 33 is going to have the name of staff, and VLAN 44 is going to have the name of net admin. Got that one right. Excellent. So we'll exit out of that. So now we need to set up our trunking modes. You can see that some portions have changed in our link lights. It's because we have actually created a VLAN 44. Later on we'll talk about spanning tree. What we're running is a thing called per VLAN spanning tree across this network. So it needs to run correctly on each VLAN and have every VLAN named on every switch. And that's what we've just done, and that's why it's solved a portion of it. But we still have this mismatch. So let's just solve that bit. So interface range FA0/122 is going to be our trunks on this switch, because those are the two connections to the other switches. Switch port mode, we're going to force it to be trunking again, and then switch port trunk native VLAN 44. Now it unblocks it all. I'm waiting for everything. Okay, so spanning tree, not CDP, has unblocked the inconsistent port. So everything's restored according to that on those ports. So at the moment we're actually running everything quite nicely. So let's just have a look at switch 2 and show our running config. Just to have a look. Show run. So what we've done is created these two, or configured these two interfaces, so switch port trunk native VLAN 44 and switch port mode trunk on both of those interfaces, because they are going up and should take trunking traffic, which implies tagged VLAN traffic, but also native, which is that little bit there, untagged. And all those three interfaces out of that top switch, and these two interfaces, and those two interfaces on the bottom two switches, are in trunking mode. We haven't played with any of these other ports at the moment. This one still has incorrect information. We will be taking that address off VLAN 1 on this switch, but at the moment it's just sitting there, so we'll clean it up a bit later. And generally standard config, everything else is good. Good. So we've set up our trunks on those three switches. So we're in a good spot at the moment. So let's go back to switch 1. It's got all our native mismatches and corrections, and all the rest should be in there somewhere. So one thing we should look at actually is our Vlan brief. So show Vlan brief, and everything is pretty much the same as we had it before, because we haven't allocated any VLANs to any ports, except for one thing. If you have a look on the right here, on the ports, we're actually missing ports 1 and 2. They are actually in trunking mode. So they won't appear as active ports because they're trunking. They are trunking and will support all VLANs going through it, so they won't appear in this show VLAN brief space. So where can we see them? If we show interfaces trunk, get that right? Yep. We can actually see it there. So this command, show interfaces trunk, says that those two ports, FA0, 1 and 2, their mode is on, the status is trunking, the native VLAN is through VLAN 44, and the actual trunking encapsulation is 802.1q. So you should remember that. That's the standard for trunking. 802 is all our Ethernet. .1q is the trunking switch to switch stuff. So in here, the VLANs that are allowed on the trunk, because we can later on with port security is allow certain VLANs up and down our trunks, is saying that 1 to 1005 are allowed. The VLANs that are allowed and active in this whole domain, 1, 22, 33, 44. 22, 33, 44 we created. VLAN 1 is the one we can't get rid of. And VLANs in spanning tree forwarding state are not pruned. Pruned is a VTP, VLAN trunking protocol thing, which we'll do in another video. Has got those running on F01. It's not on F02 at the moment because this one, in another video we'll do spanning tree protocol. One port needs to be in blocking mode, so it's actually blocking data going in and out of that port to prevent broadcast storms in spanning tree. So that's why we've got none there. So good, looking alright. Let's pop in. So that's our trunks done. Let's pop in and actually configure these two bottom switches and configure these VLANs to separate that PC from that one. So at the moment they're all on VLAN 1, so we've got to take them off. Okay, so configure terminal. So interface range again. Now you can do this interface range as individual interfaces, put a comma between them. I'm kind of doing it a bit cheaper and dirtier. I'm just doing the range of FA0/3 to 10. If you wanted to put port number 24 in there, it should take it. No, it doesn't like it. Prefers that one. We actually don't want 24 in there because it's not part of my design. But if you want to put multiple ports and separate them with a comma, generally no space, just a comma and then the next port. So you can do individual ports, ranges, whatever you like. So we'll just do 3 to 10. And we need to set up these as access ports. So switch port mode now, question mark, there's our access. They are going to be edge ports. So we're going to force them to be access ports. And then switch port access, that's similar to switch port trunk. In this case we're not using anything native, we're just going to go straight in and say we're going to put it onto a particular VLAN. So the VLAN that I want, according to my design, is 22. So just quietly, having a good design is a good thing. So I've just allocated ports 3 to 10 to VLAN 22. So let me just see that. So I'll do show VLAN brief because I'm further down the into the operating system. I can't just show VLAN brief, so we'll do show. And now we can see in there, in our VLAN briefs, that VLAN 22 has ports 3 to 10. 3, 4, 5, 6, 7, 8, 9, 10. Everything else is still on VLAN 1. That's okay. Let's put stuff onto VLAN 33 and go from there. So I like my up arrow. So interface range is now going to be from 11 to 20 according to my design. Hit enter there. And switch port mode access is what I'm going to type in again. And switch port mode access, or switch port access VLAN 33 nails those. So good. You can see it's changed there. So this PC now will not be able to chat to this PC. They are separated. If I do show VLAN brief again, then 11 to 20 is VLAN 33 and 22 is admin. We've still got these on VLAN 1. For now, what I'm going to do is just shut them down. I'll do the range command again, and for now I'm just going to shut them down, administratively down, because I don't want anyone plugging into these spare ports. We'll just shut them down, and that's it. That switch is done. apart from IP addresses, but anyway, we'll come back to management network in a minute. Okay, so let's show our running config, and we'll have a look at it. So again, ports 1 and 2 are in trunk, and we've put native traffic onto VLAN 44. Switch ports 3, 4, 5, 6 down there are connected to switchport access VLAN 22, and switchport mode is access. So correct there. Goes up to 10, 22, and then ports 11 start on VLAN 33. And if you go right to the bottom down to port 20 on VLAN 33, and then right down the bottom we've got ports 21 to 24 and our 2 gigabits all shut down. So no one can just go and plug a PC into these ports, have it come up and gain access to VLAN 1. So far so good. So let's do the same for switch on the right here. Switch 2. So Conf T, we've already got our VLAN information in, so we're going to allocate our edge ports. So interface range FA0/3 to 10. Switch port mode access. Switch port access VLAN 22. Our range, so interface range again, 11 to 20. So we're doing exactly the same, not normal, but we'll do that. And our switch port mode is access again, and our switch port access is going to be VLAN 33. Switch port access VLAN 33 is what I'm typing in there. And the last one we had is range 21 to 24 plus gigabit 0, 1 to 2. Oh, 31. That's probably 21 there. That got me. Love a typo. 95% of your errors are going to be typos, just quietly, so part of the game is to be very logical and not talk while you're doing it, probably. Okay, and this one we want to shut down. So let's have a look at everything that we've got there. So show Vlan Brief. Let's double check. Okay, so we haven't taken these guys off VLAN 1, so 21 to 24 and gigabit 1 and 2 are on VLAN 1. We don't know if they're up or down. On 22, VLAN 22, we have 3 to 10. On VLAN 33, we have 11 to 20, so far so good. We're meeting our design requirements. Ports FA01 and 2 do not appear on the right hand here because they're in trunking. So show interfaces trunk. And this much looks exactly the same as what we had on switch 1 on the left there. Or switch 3, I think it was. So good. Everything is working. One more thing we need to add is our interfaces for the management VLAN, so port 44. We need to create that, but let's just check something. So I want to ping from this machine to this machine. So what we've effectively done is created 3 broadcast domains across this switch network, and you can think of them as 3 kind of layers, one sitting above another. And each layer cannot talk to each other once they get into the switches. So VLAN 22 is one layer, so everything connected to VLAN 22 is a logical layer of connectivity, a broadcast domain. Same for VLAN 33, again a logical connection between devices in VLAN 33. And VLAN 44, which we haven't done anything to yet apart from put it into our system, is another layer that we're going to manipulate. So let's just pop into simulation mode here. I'm just going to use the basic PDU or simple PDU here, and I want to ping from this PC to that PC. Now what I want to see is actually the ARP, because it's going to broadcast this ARP. And what I'm expecting to happen is this goes into the switch and it'll broadcast it out of every port that belongs to this VLAN. So let's see, let's capture forward and go into our switch. And we'll capture forward again. So it didn't go down this path because spanning tree is blocking this port. Capture forward again. It went up this path because that's a trunk, and it went down this path because that's a trunk. Hit the end device, doesn't like it, and there's other reasons for that. We'll come back to that. Doesn't mind this one, and it broadcasts it out of every port. So you see it went across there. This one kills it because it doesn't like it. Went down this path. One thing you'll notice is it did not go down this path, and it did not go down this path. They are not part of the same broadcast domain. And our ARP will come back. Now let's just we'll get right to the end here, and we'll have a look at this inbound PDU and outbound. So the inbound is coming into our traffic. Outbound is going to go out of our switch into our traffic. I don't know what language I'm speaking now. So outbound will come out this path, and if you look at the frame up here, there is a subtle difference between the two, and it's this little portion added in there, this SFD. The outbound still has source and destination MAC addresses. Data is our ARP protocol running in, frame check sequence, a bit of preamble. Type 806 is in there, but this portion coming in has this SFD and a couple of other bits added in there as well. And this is the trunking information. It's the tagging that goes on in this Ethernet frame, is this sort of information. So you can see that when it comes out of the switch back to our end devices, it's untagged out of the switch. When it's going across our trunks, it is tagged with this data here. So let's just go back a little bit. So let's go back to our first ARP. We'll have a look at that one. And there's our outbound PDU, so it's a well-formed frame, Ethernet 2 frame. And then we'll capture forward that one. And we'll have a look at it coming in. So the inbound is again our normal frame, and outbound has these tagging information, or this tagging information added to it. And if we go the next step up, the inbound frame into this switch still has the tag on it, and outbound still has the tag on it. So while we're going down and through our trunks, we have a tag because we are part of VLAN 22. Once we get out of our switch, so let's capture forward that one, and down this path, so this one coming down here to saying what is your MAC address, the outbound and inbound PDUs of this PC is untagged. So the switches, once we get out, we untag our data. So there it's shown a little bit of what we're doing across this network. Data goes in, frames go in, gets tagged in the PC. Because of the tagging in that VLAN 22, that frame will not go down VLAN 33 ports or any other VLAN 44, VLAN 1, whatever other things, but it will go down anything that belongs to VLAN 22. It'll go down this switch, go down that switch, and it goes up these trunks that are going through between everything. So far so good. Last little thing we need to do is to give ourselves some sort of remote access, which is going to be our network administrating VLAN, which is VLAN 44. So let's pop onto the switch on the bottom left. We don't want to play with interface VLAN 1. We actually want to separate our management VLAN now from VLAN 1. So in our initial config, I don't know if you saw that video, we used interface VLAN 1, but now we won't. We're actually going to go for interface VLAN 44. So we're going to create a new VLAN, or a new interface, sorry, not a new VLAN, a new interface, and it's called VLAN 44. Now, in actually doing that, what I've done with this virtual interface, the switch virtual interface, or SVI, not only have I created this interface, but I've also added it to VLAN 44. So I need to put an IP address into that. Now I'm out of this network range here, so my address needs to belong to the correct network number. We're now looking at layer 3 information. So 192.168.10 dot something. So down here, this is switch 3, switch 1, switch 2, and we're going to have a gateway on our router later on. So let's make this, so it's going to be 128, let's make it 133. So, whoop. And there's our subnet mask. Now, interface is changed to up, but for some reason I've always just put no shutdown in there, even though it is up, it's all good. As soon as you've got a cable plugged in, actually the trunk cable, the interface should go up. So 133 will be my IP for this one. I'll make this one 132, 131, and my gateway, which I need to add in here if I want to manage it all. IP default gateway 192.168.129. Sorry, 10.129. Again, mouth going before the brain. So that switch is now fully configured. So let's pop over to switch 2, and I'll create my interface VLAN 44. So again, I'm creating a new interface and adding it to VLAN 44. And this is where you want it really created early. To just do that on the fly doesn't really create the VLAN. So create your VLANs first. So our IP address on this switch is going to be 192.168.10.132, I think you said. And there's our subnet mask. No shutdown. And we'll exit that and put our gateway in, because this is now a different broadcast domain. So IP default gateway 192.168.10.129. Now I'm just pulling these things out of my head because I've got an idea of the plan. So one thing you might be thinking about is where these numbers come from. They come from a good plan, so make sure your planning is good. We'll come back to switch 2 in a minute to talk about stuff, but let's just pop up to switch 3. And we'll go conf t, interface VLAN 44 again. The IP address we're putting in here is going to be this one with that subnet mask. So switch 1, I've given it like a 1, so it makes kind of sense. And putting in no shutdown doesn't really change anything because the interface is up. And I'll put in my default gateway address here as well. Same default gateway for all these ones, different IP address for all those switches. Okay, so let's just have a look at our running config for switch 1. So show run, and basic stuff that we had before from ages ago. Still not too sure why I got enabled password in, but let's look at the bits that we've actually changed. Here's our trunks. Now, if you remember, this is a distribution or core switch or a compressed core. So we've got 3 trunking interfaces there. I haven't touched all these other interfaces at all. So from gigabit 0, 1 and 2 down to, or across to fast Ethernet 4 to 24, they're all still part of VLAN 1. Haven't shut them down. Generally this switch should be locked away in a cabinet somewhere, but you should go in and actually do something to those ports. Shut them down, just to stop people plugging things in. This is where we've created our interface VLAN 44, so now you can see it there. It's created a MAC address for itself. We've got an IP address of 192.168.10.31, default gateway. We've added those bits in to our system. We're not using VLAN 1, interface VLAN 1 in this case. And everything else is there. So what we should be able to do is actually telnet in from this switch to another switch. So telnet, we can run the command like this, so 192, actually we should ping first, shouldn't we, just to check connectivity. So 192.168.10.1, 129 doesn't exist, so 132. Let's see if that works. So the first one failed, second one failed, third one failed. Wow, not looking good, is it? 192.168.10.132. That should be this address down here, shouldn't it? 192.168.10.132, VLAN 44. Well, that's a nice error. I don't know if I actually want to play with that. 192.168.10.132. Let's try ping 133. I'm guessing we're going to get the same errors. And it should work. No? Got different errors. Or no error there. I'd like to know where my error is in this one. It's still failing beautifully. 192.168.10. Now I'm confused. Show running config. Doesn't take much to confuse me. Interface VLAN 44, IP address 192.168.10.132. The correct subnet mask, isn't it? 192. Let's have a look at our config for this one again. Show run down the bottom. VLAN 44, IP address 192.168.10.131. Correct. No, it's got me. Ping 192.168.10.131. Now if it's failed coming this way, it should fail going back. I do not understand that. We will leave that one. We won't hassle about the system there. But let's just go back to... I pinged myself there, didn't I? 131. So 131's quite happy. Let's telnet into that just to show it. 192.168.10.131 is what we're telnetting into, and this is trying to get access to this switch remotely. So we can do it from switch to switch. So our VTY password is Cisco, and we're going to enable SCO. Didn't like us the first time. Enable class, and there we're on switch 1. Ping 192.168.10.132. That should fail as well, because obviously there's an error in there somewhere. So I'm going to have to go back and look for that. But that's okay. We can work that out. We should be able to ping 133, which is really quite funny. I don't know if you've noticed this, my brain is going too slow today. I've telnetted into myself up there on switch 1. What I actually want to do is telnet into switch 3. So let's do that. So 192.168.10.133. Now you'll notice I have not put telnet in here. It's not an error. It is used by default. So Cisco, switch 3, enable class. We're in switch 3 now. So quite funny in a way. I've telnetted into myself and now I'm telnetted into switch 3 down there. Very sad in a way. Too quick for typing. So anyway, let's exit this. And we're back to switch 1. Then we exit switch 1 and we go back to switch 1, which is funny to telnet into yourself. Still don't have access to switch 2, but let's just pop on there and we'll show our running config. And we've still got this address here on VLAN 1, which I'll clean up. I'll get rid of that. This address looks correct. Potentially this one is conflicting, but it will be a conflict actually, because this one's subnetted, so it's probably having a little hissy fit. This address here is actually in the same range as this network, so I'm guessing that's our problem. So let's clean up that interface. So conft interface VLAN 1, no IP address, should take it out. So let's show run again, right to the bottom, and VLAN 1 has no IP address. Interface VLAN 44 seems to be quite happy. Let's just see if we can ping something else. So 192.168.10.131 may work. Yep, could. So it had a conflict in it. Lovely errors. Okay, so that's what we've done. We've set up our VLANs. Show Vlan Brief will show us our VLAN information. So what's left on default, what's on VLAN 33, sorry, VLAN 22, beg your pardon, what's on VLAN 33, and you'll notice that nothing's on VLAN 44, but we know that if we do a show run, that interface VLAN 44 is on VLAN 44. By creating that interface VLAN 44, it's added this virtual interface, switch virtual interface, onto VLAN 44. Now, none of these PCs can actually ping these switches because they're on separate VLANs. They've been tagged as separate. And this is actually what we want. The trunking will take VLAN information across and it'll be tagged. We've taken native traffic off the default, which is VLAN 1, and put it onto VLAN 44. Because VLAN 44 is our management, our net admin VLAN, and putting native VLAN, normally not a good idea, but as far as CCNA is concerned, that's fine. In production environments, you won't do that. You'd actually have a separate VLAN for native traffic. But everything in there, not too bad. Let's have a look at our directory listing of our system. So in our directory, we've got our startup config, and we've got our VLAN.dat, which is our VLAN information. So if we're going to erase this information from our switch, we would need to clean out those things. So erase and delete are two options. Don't delete Flash as a whole because it'll wipe everything out, including your operating system, and that's not cool. But yeah, all in there and all working so far. So the next video we'll do is a router, or putting in some routing process onto this network, but at the moment we've separated this network, VLAN 33, from VLAN 22, and I've pointed to the wrong ones there. We've put a management VLAN onto the switches with VLAN 44 and given it a separate IP schemes for each of those, even though VLANs don't have IP information. So next video we'll do router on a stick. We'll talk about that bit there. So good, thank you for that. See you later.